Now we're going to talk about how to do hypothesis testing with two samples when we're comparing means. So this is from your textbook sections 9.3, comparing means from two independent samples. So the claim that we're going to look at in this example is that women's pulse rates are higher than men. So we have two different populations. We have women and we have men. So we're going to label women population 1 and men population 2. So now we're going to go through the symbols you would see in this section. Very similar to when we had proportions, we'll have the little subscripts 1 and 2s for population 1 and population 2. Otherwise, there'll be the symbols that you've seen throughout the different chapters. So population 1's mean will be mu1. And population 2's mean is mu2. The sample size we know is n, so we have n1 and n2. And then sample means are x bar. So sample 1's mean is x bar 1, and sample 2 means x bar 2. And the sample standard deviation is always s. So we have s1 and s2. So now we need to set up our null and our alternate hypotheses for this situation. So here we're talking about means, so we're going to use the mu's in there, the funny m's. So the null hypothesis, remember, always has equality, so it's going to be mu1 equals mu2. And we are saying our claim is that women's pulse rates are higher, that mu1 is greater than mu2. So that will be our alternate hypothesis. So we're going to test this claim at a significance level of 1%. So alpha is going to be 0.01. Okay, so we want to make sure we label everything consistently. So here we have men's pulse rates, so those are going to be population 2. And here we have women's pulse rates, so that's going to be population 1. We're going to put the population 2, the men's, into L2 and the women's into L1. So you're going to go stat and edit, clear anything that you have in there, and put those in. I'm going to pause the video, put them in. I also recommend that you pause the video right now and put them in your calculator. Okay, so we have the 12 women's pulse values in L1 and the men's in L2. And notice that N1 and N2 don't have to be equal. Sometimes it may not be possible to get exact same size sample sizes, and that's okay. Okay, so we want to know, are these results pretty much the same, or are the women's pulse rates significantly higher? So both of the sample sizes are pretty small, but since humans' pulse rates are normally distributed, that's okay. Okay, so it says follow the following key sequence to get the hypothesis testing. So just like you've done with the other hypothesis tests, you're going to go to stat, go over to tests, and we're going to go down to number 4, the 2 sample t-test. Okay, so we're going to choose data, keep it on data here because we've just put that data in. We're going to have L1 in list 1, L2 in list 2, and put 1 for both of the frequencies. So that's already set up there. Since we were claiming that mu1 was bigger than mu2, that's what we're going to choose on the calculator, the third option. And we do not want it pooled. So then we're going to go down and hit calculate. Okay, so this gives us our test statistic of negative 1.16, our p-value of 0.87. And remember, alpha was 0.01, so this is much bigger. So since p is greater than alpha, we do not reject, which means we do not support the claim that women's pulse rates are higher than men's. Okay, we're going to try another one. So a company conducted a contest for promotion. Some of the employees who were not promoted filed a lawsuit claiming that the competition involved discrimination based on age. So the claim that we're going to test is that the non-promoted employees were significantly older than the promoted employees. So the two populations will be the non-promoted. So that's going to be population 1 and the promoted. So that'll be population 2. So here we're talking about the average age. That's our mean. So our null hypothesis will be that mu1 equals mu2. And our claim is that the non-promoted population 1 is older, so mu1 is greater than mu2. So we're going to let alpha be 5% or 0.05. So our population 1 are the non-promoted employees. So the sample size N1 is 23. The average age, so that's X bar 1, is 47. And the standard deviation S1 is 7.2. Population 2, the promoted employees, our N is 30, our sample size is 30. Our mean age, X bar, is 42.5. And the standard deviation is 5.9. So again, we're going to go to stat, over to tests, and do 2 sample t-test. And this time, instead of data, we're going to put in just the stats. So for X1, we have 47. SX1, we have 7.2. For N1, we have 23. For X bar 2, we have 42.5. For the standard deviation, 5.9. And the sample size, 30. And again, we're claiming that mu1 is greater than mu2. We do not want it pooled. Okay, and we're going to hit calculate. So the the test statistic we get here, T, is 2.44. The p-value is 0.0096. And notice that we let alpha be 0.05. So p here is less than alpha. It's smaller. So we reject the null hypothesis, which means we support the claim that the non-promoted employees were significantly older than the promoted employees.